In the last lesson, we learned the double angle formulas, and the double angle formulas aren't so useful for getting like new trig values. Like, what can I do with it? I can get cosine of 60 if I know it's cosine of 2 times 30. But that's not a new thing, cosine 60. And really, I can't get anything new with the double angle formula that I wasn't able to get already with the sine and cosine tangent of a plus b formulas. The half angle formulas will get us some new things. And the half angle formulas are based on the double angle formulas. So that's why we study the double angle formulas first. First, I'll just show you. These are the three half angle formulas. Sine a over 2 is plus or minus. It's plus or minus depending on what quadrant I'm dealing with. Square root of 1 minus cosine a over 2. Cosine a over 2 is plus or minus 1 plus cosine, square root of 1 plus cosine a over 2. And tan a over 2 is sine a over 1 plus cosine a. Now, the way you derive the half angle formula is you take the double angle formula. First I'm going to derive the cosine half angle formula. You take the regular double angle formula and you say, what if 2x, I'll just call that a. So now this thing looks like cosine a equals 2 cosine squared. Now this x is half of 2x, so I have a over 2 minus 1. Now I add 1 to both sides. I take the square root of both sides. Oops, I lost. Sorry. Divide both sides by 2. I have to have this 2 got canceled out. And then take the square root. Again, this plus minus, we'll see how that works later. But for now, there's the formula for half angle formula. I started with the double angle formula for cosine. Now, if you try the same trick for sine, a equals 2x, sine a equals 2 sine a over 2, cosine a over 2. It's not so easy now. I can't just isolate this because I'll end up with this cosine a over 2 involved. So the trick actually is, the way you get the sine of half angle formula is to start with the version of the cosine 2x formula that involves sine x. Remember, there's 3 versions of the cosine 2x formula. So if I make 2x equal to a, this becomes cosine a, 1 minus 2 sine squared. If a is 2x, then x is a over 2. And now you can continue this by subtracting 1 from both sides. Negative 2 sine squared a over 2. Divide by negative 2. I'm going to go like this. When I divide by the negative, I'm going to reverse the direction. Cosine a minus 1 becomes 1 minus cosine a. And finally, take the square root of both sides. And that's where we get the sine a over 2 formula. I'm not going to do the whole tangent a over 2 formula right now, except to say that it does start with the 2 things that we just got. But it's got a lot of steps before you actually get to the very simple looking sine a over 1 plus cosine a. It's not really that obvious, but that's not going to be part of this video. Well, now that we have the half angle formula, we really can't do so much with it, it seems. Like, one thing we can do, any angle we know the sine and cosine of, or any angle we know the cosine of, we can find the sine or cosine or tangent of half that angle. For instance, sine of 15 degrees. I know we got sine of 15 degrees before, using sine A minus B. But now we can get it again because it's half of 30. And according to the formula, it's going to be plus or minus. It's going to be plus because sine of 15 is an acute angle. 1 minus cosine 30 over 2. Cosine of 30 is radical 3 over 2. I can do a common denominator. 2 minus radical 3 over 2. And then I still have the over 2 from before. And we end up with 2 minus radical 3 over 4. Which I could simplify a small bit because 4 is a perfect square. So I get the square root of 2 minus square root of 3. So this is a very unusual thing, nested radical, but it is accurate and it is the answer to that question. If I put it into a calculator, I would get the same answer that I got when I did sine A minus B formula. Now we already knew how to get sine of 15 using the A minus B formula, but I can get new things now, like sine 22.5. Whether that's an important question or not is another story, but it's a question I can do now because this equals the square root of 1 minus cosine 45 over 2, which is 1 minus radical 2 over 2, over 2, square root of that, which is 2 minus radical 2 over 4, square root of that, which is this another nested radical, a lot of 2's in it. So that's a new thing, sine of 22.5. So I can get half, and I can get half of that if I want, if I really care about sine of 11.25, and I can get a whole bunch of new angles that I never had before, although I really can't get any new integers that I haven't had before if all I have is 30, 60, and 90. 30, 60, and 45, but I can get things like 22.5, things like that. And here's another typical sort of question. They tell you what cosine A is, and they ask you what cosine A over 2 is. You certainly don't want to say 3/8. Instead, you want to use the formula, square root of 1 plus cosine A over 2. Be careful here. First of all, this is positive because if A is between 0 and 180, so is A over 2. But here's a part some people make a mistake at. The entire cosine A gets replaced with 3/4, not just the A. This becomes 7 square root of 7 over 8. There's different things you can do to simplify it, but I'm happy with that, square root of 7/8. Oops, just realized I made a mistake. I need a squared in here. So this turns into 9 over 16. And this turns into 25 over 32. Actually, scratch that. This wasn't supposed to have a squared in it. We already took care of that. So I think my answer is square root of 7/8. Hope so. Now, tan theta over 2 is pretty complicated to do with algebra. I didn't even show how to do it. But there is this nice proof without words for it. Here's a semicircle. And this is an isosceles triangle, so these are both theta over 2. Now this angle is equal to the sum of those two, so it's theta. Exterior angle of a triangle. So since the radius is 1 of this circle, here we have our typical 1 cosine theta, sine theta triangle. On the other hand, we have this big triangle. I'll make it green. Actually, let's not make the really big one. Let's just make the medium-sized green triangle. So here's theta over 2. Tan theta over 2 is opposite over adjacent, but the opposite is sine theta, and the adjacent is this big side, which is 1 plus cosine theta. There's also this little triangle here. Now if this angle is theta over 2, then this angle here is 90 minus that, but this whole angle here is 90, so that makes this angle also theta over 2. And if I use that little triangle, I could say tan theta over 2 is opposite over adjacent. Well, the opposite, if this is 1 and this piece is cosine, then this piece here is 1 minus cosine, and the adjacent is that sine theta, which is the same piece as we used for the other one. So if we use this real small triangle here, we could also get this version of it. But this is the version that I told you in class, sine theta over 1 plus cosine theta. That's a more simple derivation than an algebraic one. Okay, that ought to do it.